Alright guys, today's goal is going to be to solve and justify the solution method to a literal equation. We're going to use the same problems we used yesterday. We're going to talk about the same issues. We're going to talk about the same solution methods. What we're adding today, or what we're going to work on mixing into what we did yesterday, is this justify piece. Guys, justifying these is just as easy as justifying anything else. You guys are finally starting to understand it. We're making some good progress on it. So let's just make sure that as we go through this, you're understanding piece by piece what's going on. Literally, the entire video is the same problems you saw yesterday. I'll go through each one piece by piece. You guys will take some notes at the end. There are a few problems I want you to try on your own. Alright, so this one, we're actually going to ignore this piece off to the side here. I don't know why I didn't erase it. I apologize for that. But we got V equals LWH. I'm going to say solve for, I believe yesterday we did solve for L. Today we'll do solve for W. In this problem, it doesn't matter. It works out exactly the same. Wow, my handwriting is getting really bad. I apologize right now, guys. I am running on about 6 hours of sleep since Saturday morning. And I don't even know what day it is. I think this is late Tuesday evening, possibly really early Wednesday morning when I'm making this. So it's been a few days without sleep, so just bear with me if I start to sound loopy. If I get too loopy, Miss N, Miss Ramirez, just turn the video off and teach it yourself. But we're going to solve for W. When I look at this, I look and I say, what needs to move from the same side? Well, this L right here needs to disappear. This H right here needs to disappear so that I can get W by itself. So now I know H, L need to disappear. Over here, because I'm having I had quite a few questions on this yesterday. So over here, I'm going to write H, I'm going to write L, and what I want you guys to do is think about how are they attached? How are the H and the L attached to the W? Well, let's look at it piece by piece. Between the H and the W, there's no operation, and when there's no operation, I know it's multiply. Multiplied. And again, between the L and the W, there's no operation, so again I know the two are being multiplied in my problem. And if they're being multiplied in my problem, then I think to myself, I think to myself, what's the opposite? Opposite, or the inverse operation of multiplication, is division. Opposite, or inverse operation of multiplication, is again division. So I need to use the same operation to get rid of both of these. The key here, though, guys, is that because it's the same operation, I can actually do both of them at the same time. So I'm going to come over here and write divided by on both sides. And again, what needed to be gotten rid of? I need to get rid of this L, and this H, this L, and this H. Doesn't matter which way you're looking at it. Same thing needs to disappear, so I'm going to divide by LH. Divide by LH. So over here I get V over LH equals W. That's my answer. Okay, this one's really simple, guys. I had one step here, two steps here. So when I come over here to justify, step one is always, hopefully you guys actually said it. I want you guys to get in the habit of saying it every time, because some of you are still forgetting to write it on your quizzes, your assignments, your homework, your everything. So please make sure you're actually paying attention and you always write given on number one. Number two, when we look at it, V over LH equals W. What did I do? Well, I divided by that L, I divided by that H, but I did it to both sides. And what tells me that I'm allowed to divide both sides of an equation by the same thing? Hopefully you guys said it. It's the division property of equality. If you didn't say it, hopefully you at least thought it. This should be like almost as easy for you as breathing at this point, guys. So here's what we're going to do. We're going to move on. This is pretty basic. We're going to eliminate this one. And we're going to look over here. I'm going to go through this one fairly quickly. And then you guys are going to justify it. This is actually the one that I got questions on yesterday. I actually had a student who was working on it with me and then stopped texting me, so I'm hoping he figured it out. But just in case he didn't, and just in case some of you guys had questions and didn't think to actually, I don't know, ask, let's go ahead and work our way through this one. In this case, from the same side as the y, let's say solve for y, sorry. Solve for y. On the same side as the y, I've got the 3x, and remember, we're talking about terms. The only time I write down a piece of a term is if it's in the same term as what I'm looking for. 3x is just one piece. 3x. The other piece that I need to get rid of is this 2 right here. So now I stop and I look at it. How is the 3x attached? Well, there's a plus sign between them, so that tells me it's either going to be addition or subtraction. I look out in front of the 3, it's positive, so I know the 3 is attached using addition, or the 3x is being added to my 2y. Now I look and I say, how is this 2y attached, or how is the 2y being connected to the y? Wow, I told you guys I'm really tired. How is the 2 being connected to the y? We don't want to get rid of y. Well, 2 and y are connected. There's nothing in between them, which tells me that they have to be multiplied, right? So I know 2 is attached through multiplication. So now that I know what's going on, I have to figure out how to undo it. So from addition, the opposite of addition is subtraction. And the opposite of multiplication is division. Please remember, in math, we call opposites inverse operations. That's always a good thing. Now, I can either start by dividing everything by 2, or I can start by subtracting 3x from both sides. In this case, when I look at this, this is very important, guys. 2 does not go into 3. 2, 3, don't work out evenly. 2, 9, don't work out evenly. I can't divide everything by 2 without causing fractions, and we all hate fractions, so let's avoid them. So I'm going to start by subtracting the 3x. Minus 3x from both sides. Those two cancel out, and I get 2y equals. Now, just like when we were working with variables on both sides of the equation, we had to be able to move them back and forth. When I'm looking up here, this 9 and this 3x are not like terms. I can't combine them. So what I'm going to do is I'm going to just write it as negative 3x plus 9. Okay, that's step 1. Step 2, the opposite of multiplication was division. So I'm going to divide this side by 2. And when I divide this side by 2, guys, the beauty of formulas, the beauty of literal equations, which is what we're calling formulas now, is I don't care if it's purely simplified, if it's in the simplest form possible. That's not the purpose. The purpose is, can you look at a big picture concept? Can you take the conceptual understanding of solving an equation and apply it to something that's just completely out of your comfort zone? Those 2's cancel. I get y equals negative 3x plus 9 over 2. Here's what I want you guys to do. Step 1, step 2, step 3. Please justify these in your notes. Go ahead, pause the video, move on when you're ready to go. Alright, step 1 is obviously given, always will be given, always has been given. Step 1 is given. Step 2, we subtracted from both sides. That tells me it's the subtraction property of equality. Step 3, we divided something into both sides. That tells me it's the division property of equality. Let's go ahead and move on to the next one. P equals 2L plus 2W. I want you guys to actually go through this same concept as the last one. We're going to do solve for L. I want you guys to identify what needs to move, so I'll help you out with that. It's 2W and 2. You need to tell me, how are those two attached? And then what's the opposite? Go ahead, take, well, as much time as you guys need for everybody to get on the same page. No, I lied. Don't take that much time. Take 1 minute, go ahead, figure this out. How are they attached and what's the opposite of that? And then come back to me. All right. So 2W, you should have said, is attached through addition because there's an operation in between. It is addition or subtraction. The sign in front of the 2W is definitely positive. Okay. And then the 2 in front of the L is simply attached through multiplication. So we're actually, even though it looks completely different, we've got more variables, it's a little messier, we're dealing with the same concept as last time. Now let's go ahead and develop the opposites. The opposite of addition is subtraction. Opposite of multiplication is division. Alright guys, I want you to go through. Remember, you don't like fractions, so we don't want to do division unless everything is divisible by the number we're dividing by. I want you guys to go through and do division, subtraction, or subtraction, division, however you want to look at it. Write a justification, double check it with Miss N, and then when you guys are ready to move on, go ahead and push play again. Alright guys, this time I'm just going to highlight the variable I want you to solve. It's x. Take 2 minutes. 2 minutes and 2 minutes only. I want you to develop the entire process. Tell me what needs to move, how it's attached, how you cancel it out. Implement it and then justify. So, what moves? How attached? How cancel? Implement. Justify or prove. Okay, go ahead, take those 5 steps. I'll give you guys 2 minutes. Alright, you guys should be ready to move on. We're actually going to skip this one, so just pretend it never even showed up. There are 3 problems on the board. What I'm going to do is I'm actually going to underline the variable you need to solve for in each situation. This one's going to be fun. I'm going to help you guys out on number 3 here. It's actually L equals P minus 2W over 2. And I want you guys to isolate the W. Go ahead, I want you guys to solve for the indicated variable, justify your solution. Do it on a separate sheet of paper. You're going to want a whole sheet of paper for this one. Miss Ann will collect it at the end of this, or when she's ready. After this, you guys have a quiz. After the quiz, you guys should be getting a worksheet. Alright, if you don't have time for the worksheet, that's Miss Ann's call. If they're there when I come in on Saturday to pick up work, that's fine. Okay, just make sure you guys are actually getting this done and are ready to go. Ladies and gentlemen, have a great day.